I am an avatar organized by Dr. Alemi to present this lecture. This presentation focuses on creating interaction plots. Interaction plots are case-based reasoning. For simplicity, let us start with interaction plot for predicting y from 3 independent variables. Data must be standardized prior to plotting. Data must be revised so that increases in x must not lead to decreases in y. There should be a monotone positive relation between x's and y. If data are transformed so that the assumptions are met, on the y-axis, we plot the probability of the case. On the x-axis, we list the combinations of the variables in the order of their corresponding y value. The first value on the x-axis is when neither x2 or x3 are present. Next is when only x2 is 1 and x3 is 0. Next is when only x3 is 1 and x2 is 0. Last is when both are set to 1. 2 lines are drawn. The first line shows the probability of cases in which x1 is set to 0. The second line shows the probability of cases in which x1 is set to 1. If the 2 lines are parallel, x1 adds the same amount to each combination of x2 and x3, so there are no interactions. The deviation from parallel line indicate possible interactions. Here x1 and x2 are potentially interacting. Here we see a violation of order, where monotone order is not kept in the top line. Here are some examples of interaction plots. In this example, we see a funnel opening to the right, where cardiovascular illness are present. This suggests an interaction between education and cardiovascular illness. To the right, you see linear relationship between levels of infection and cardiovascular illness. Let us look at real data. In this interaction plot, the numbers are nominal and meaningless. Each number shows a different set of comorbidities. For example, the level 1 in x-axis indicates that there are no comorbidities present. The level 9 in x-axis indicates presence of a specific set of comorbidities. For example, diabetes, hypertension, and depression. The y-axis shows the probability of death in 6 months. 2 lines are plotted. First line is probability of death when stomach cancer is not present. The second line gives the probability of mortality when stomach cancer is present. The difference between the 2 lines is only stomach cancer and nothing else. At each level, same comorbidities are shared between these 2 lines. The difference between the 2 lines is large when no comorbidities are present. The impact is small in levels 29, 30, and 31, where the patient may die from many other serious comorbidities, for example, other cancers. It is clear that the impact of stomach cancer depends on patients' comorbidities, sometimes larger, other times smaller. In the set of comorbidities in cells 19 and 20, the drop in the probability also suggests an interaction effect. Interactions are added to the model so that we get 2 parallel lines. For example, a 20% interaction adjustment to levels 19 and 20 and a 10% adjustment for level 26 makes the 2 lines more parallel, thus appropriate for estimation of main effects. Interaction plots tell you where interactions exist and how large they may be. I hope this presentation has helped you understand how to detect and adjust for interactions.